All right, so the next thing I want us to review is definite integration. So that's using the fundamental theorem of calculus. So if we had a problem like the integral of x squared minus x dx, if I just left it like this without the limits of integration on it, this would be indefinite integration. And when you found your antiderivative, you would put a plus c on it. So now if I put some numbers on this, like say we want to go from -1 to 2. So now I'm wanting to evaluate this integral now. So this is definite integration because I'm definitely going to get a numerical answer. All right, so we'll do the antiderivative. So that'd be x cubed over 3 minus x squared over 2. I don't need the plus c because I'm going to evaluate from -1 to 2. So then we do our fundamental theorem of calculus. And we're going to plug a 2 in first. So 2 cubed over 3 minus 2 squared over 2. And then we're going to plug -1 in. So -1 cubed over 3 minus -1 squared over 2. And if you were on the free response part of your test, you would be finished. That you would totally be done with this problem. But if we're doing multiple choice, we might want to finish out the math. So 2 cubed, that's going to be 8/3. And this will be minus 4 over 2 will be minus 2. And then I'm going to go ahead and keep this in parentheses, keep my brain straight, subtracting this answer. So -1 cubed is going to be -1, so that's -1/3. And this is -1 squared, it would be +1, but I'm subtracting, so -1/2. So I have 8/3 minus 2, distribute the negative, plus 1/3, and then plus 1/2. All right, so then I've got 8/3 plus a 1/3, that's going to be 9/3, so that's 3 minus 2 plus 1/2. So my answer is going to be 1.5 or 1.5. All right, so you're just evaluating integrals. Hopefully you remember how to do definite integration. Let's do one more. Let's say I have 5x to the 4th minus 3. Oh, let's throw something tough in there. There we go. Let's just do some wild. All right, and so then we want to go from, let's do 0 to 8. All right, so what I want to do, I want to find my antiderivative first. So this would be 5x to the 5th divided by 5. All right, this is going to be minus 3. All right, so this right here, remember, this is x to the 1/2. So what I want to do is I want to add 1. So x to the 3/2, because you add the bottom to the top, add the denominator to the numerator. And then instead of dividing by 3/2, we multiply by 2/3 plus, and the antiderivative of 1 over x is ln x. And I don't need the plus c because I'm going to evaluate from 0 to 8. So now I do the fundamental theorem of calculus. So I'm going to first throw in, let's see, first I can get rid of these 5s and I can get rid of these 3s. All right, so I'm going to throw in 8, so that would be 8 to the 5th minus 2, 8 to the 3/2 plus ln 8. And then I want to plug in a 0, which can't do for ln, so I probably should change that number. Let's just change that to a 1 or something so that we can actually evaluate that answer, because you can't do the ln of 0. So let's make that a 1 right there. All right, so we put a 1 in next, so we're going to have 1 to the 5th minus 2 times 1 to the 3/2 plus ln of 1. All right, so this being the case, the most I could simplify here, I mean, we're not going to multiply this out, and we're definitely not going to do 8 to the 3/2. So I could leave this answer like this. I could make that a radical if I wanted to, just to show what that equals. Then here it will be minus 1, and of course this is going to be plus 2, and the ln of 1 is 0. So this would probably be the simplest I'd want to make it. because we would probably type that in a calculator either and get a decimal as well and get a decimal answer anyway. Remember, you can always math 9 these, but sometimes you have to do these by hand on your calculator. So, on your paper instead of doing it math 9 in the calculator. So always remember that we need to know how to do antiderivatives and do the fundamental theorem of calculus without using a calculator. We have to know how to do that by hand. Let's do one that's got trig. So let's go from pi over 4 to 3 pi over 2, just to make something up here. And let's do secant squared. Let's see, might not be able to do that one because it might give me something undefined. I'll change my limits of integration. We'll do secant squared, but I'm going to have to change this limit of integration. I'm going to have to change this. Let's do, we'll just do pi over 3. All right. So we want to do the antiderivative of secant squared. Well, we know that's tan. I don't need my plus c because I'm evaluating from pi over 4 to pi over 3. So next I do the fundamental theorem of calculus. So I'm going to put pi over 3 in first, so the tangent of pi over 3. And then I'm going to put pi over 4 in there, the tangent of pi over 4. So let's see, the tangent of pi over 3. I have to think on the unit circle here. All right, where am I at pi over 3? Well, pi over 3 is 60 degrees. So that's over a little and then up a lot. So my tangent is sine over cosine. So that'd be the y-coordinate over the x-coordinate. So that's going to be radical 3 over 2 divided by half, which is going to be radical 3. And then for pi over 4 is in the middle. So that's your radical 2 over 2, radical 2 over 2. And tangent is y over x, so that's going to be 1. So that's my answer. Radical 3 minus 1 would be the answer to this integral. So there's a handout for you to practice doing the fundamental theorem of calculus, just making sure you know how to do definite integration and do the fundamental theorem. So practice those just to refresh what we've learned from last year.